Year 11, I'm back. The last of the videos for this topic, what do you know? And this is transformations. Just a look, read that. Yeah, look at that. Transformations. Okay, what this means is we're going to sort of take something that's familiar, right, a nice regular graph, and we're going to change it. We're going to move it around, we're going to flip it over or something, and we're only going to do some of these. We are interested in vertical and horizontal translation. Means moving the whole graph as it is, up and down, side by side. Righto? Shift the whole graph. Don't change the shape of it. Don't change the side of it. We're just going to move it around somewhere. Right? Obviously, shifting it up and down, vertical translation, shifting it side to side, horizontal. That's the first thing we're going to look at. How does that work? I'm glad you asked. Well, vertical translation, what I want to do is I am going to change the y. Now, I'm going to replace y with y minus the amount I want to move it. Okay, now let's say, what have I written here? That's a pretty complicated way of saying these things. If I want to move my graph up by 1 unit, then instead of saying y equals my function, I say y minus 1. Right? It's the reverse. Right? We change the sign. Y minus 1 equals my function. Right? That will move it up 1 unit. Y plus 1 would move it down 1 unit. Equals whatever. Now I can rearrange that as I get there. Horizontally, I replace the x with some other number. Right? X minus the amount I want to move it. Let's see how that works. Now here is a graph of y equals x squared. Right? This will probably make more sense with an example. This is y equals x squared. Right? This is our parabola. Now, I want to do x squared minus 1. Well, that is the same as, right, that is the same as saying y plus 1 equals x squared. That means instead of y equals x squared, that's my familiar one, this is y equals x squared. Instead of this, I now have y plus 1 equals x squared. That means it's got to go down. Right? I change the sign of that. And now it goes, oh, well, that really shouldn't go off. That's a bad looking parabola. Right. Minus 1. Oops. Minus 1. Okay, we wrote it like this. Right, so that's close to our original function, and now this is y equals x squared minus 1. Okay. Now this one here, right, that's not y equals x, this is y equals x squared. Right, I've written something else, right? I have replaced the x with x minus 2. That means I am moving it across 2 units the positive way. Right, change the sign of that. I'm going to cross here too. So it's going to be over here, like this. This is going to be 2. That's y equals x minus 2 all squared. Right, shuffle it across. We haven't changed the size, haven't changed the shape. We have translated it. Right, we've translated it to the right 2 units. This one, I'm going to translate it to the right 3 units. And, right, if I put that over there, that would be plus 2. That will be down 2. So to the right 3. So we go across 3, down 2. That's going to be my new vertex. And so it's going to go like this. And like this, I reckon. That's y equals x minus 3 all squared minus 2. Okay, so there's my new vertex at 3 minus 2. Okay, pull that over there so it's with the y, right, so that it looks a bit like y equals x squared, but it's y plus 2 equals x minus 3 all squared. Okay, so y plus 2 means down 2. X minus 3 means to the right 3 units. Now, there are translations. We're going to move on. We're going to make it a longer video. That's moving it side to side, up and down. We've also got reflections. Okay, so this means as though it's reflected in a mirror or it's flipped over. Now, if I take my y equals x squared and I flip it, if I rotate it or reflect it about the y-axis, it looks the same because it's symmetrical. Okay, so that's not much help to us. We'll look at some different things. Now, to reflect a function in the y-axis, the vertical axis, right, so I flip it, right, oh, where's my hand? There you go. Flip it like that. Flip it over. Right, flip it in the y-axis. What I do is I replace the x with a minus x. To flip it in the x-axis, Right, put it like this. Put it in the x-axis, like this. Then I replace the y with minus y. So, here is y equals 2x. I want to reflect that in the y-axis. Right, to reflect it in the y-axis, I change the x. Okay, so that is y equals 2 to the negative x. Replace x with a negative x. There you go. And that will be reflected in the y-axis. To reflect in the x-axis, I say minus y equals 2 to the x. Right, which I could also say is y equals negative 2 to the x. Right, because I could divide both sides by minus 1. So, we're going to sketch all three of them on the same axes. Here's our axes, x and y. Now, y equals 2 to the x. Remember, this is an exponential. Looks like this. Right, crosses here at 1. Now, if I reflect that in the y-axis, then it's going to be like that. Remember, there's an asymptote. That's Mrs. Buffia somewhere. There's Mrs. Buffia pretending to do maths. Well, hang on to Mrs. Buffia, you won't see her again. Now, we have reflected this first one. So, this is my exponential. This is y equals 2 to the power of x. This is y equals 2 to the negative x. Right, you can confirm that with maybe Desmos or something. And finally, right, negative y equals 2 to the x, or remember that's y equals negative 2 to the x. That's going to be that's my original reflecting the x-axis. Will look like this. Right, at negative 1 down there. Y equals negative 2 to the power of x. There we go. That is reflection and translation. Reflection and translation. Pretty tough. Pretty useful. Right? You can apply those principles to all of our functions. You can try. Wonderful. Good work.